Okay, so I'm going to give a little overview of camera and focus on a other type of metadata that is very important in terms of analysis, sort of in terms of how we built our framework. And so the idea of camera is to provide a portal wherein users can come in and utilize various analysis pipelines and make that easy for the user itself. And so really, the focus is on the data, but also the algorithms and how you tie those algorithms together and do this in a community type fashion. So at the heart of this is the database itself, and I mean we've heard a lot of talks this morning already about the necessary metadata that's required, and so camera, like a lot of these other resources, does support community standards that are being promulgated by the GSC. Which allows one to do, things in terms of, different visual displays such as, locations or filtering by various metadata aspects and using that in advanced filtering, advanced search capabilities. Now, one of the things that we do provide in camera is the ability to actually then use those metadata searches, advanced search capabilities to develop your own data source. So you can basically create your own libraries that you'd wish to use in your analysis based on all these search queries. So in a sense, being able to do a meta-analysis across sort of a restricted subset of data, which becomes important, with the explosion of the amount of data that we have out there, any way that you can sort of restrict that makes it better computationally. However, what I wanted to sort of focus on here a little bit was about how we actually tie those analyses together. So there's sort of another type of metadata that's involved with the generation of data, and that's actually how the analysis was processed through. And so this is the whole idea about provenance. And so within camera, we use a workflow engine sort of at the core that basically takes what a scientist might want to do in terms of the types of processing and formalizes that into a specific document that describes how this workflow is actually processed. And then as that is going through the system, the provenance of this data, so how and when it was processed, is being stored. And what this allows one then to do is then have these component building blocks so that you can have different workflows, different pipelines that one can then tie together. Now, at the core of this workflow framework is Kepler. It's a workflow system developed out of the US, funded by NSF, so it's very similar to Taverna, which is sort of the EU equivalent that is being developed out of Carol Goebel's group at University of Manchester. And both Taverna, Kepler, and these other workflow engines have sort of a provenance framework that the community has been developing. So provenance standards for how one actually records how data is flowing through different pieces of the analysis. And this has actually also been picked up lately by the W3C, which is developing their own provenance framework. And so there's a little work there looking at how these different provenance frameworks come together. Now, one of the things within Kepler, one thing I did want to mention is that there is a new BioKepler project. So this is a newly funded NSF award to Kepler. So it's an open community project. They're looking for different use cases, but this is really funded to extend sort of Kepler's functionality in terms of using different types of computing architectures, matching that with the data and the analysis that is brought in to make it easier for people doing various types of analyses to utilize compute resources that they might not normally have access to. And so this is a project that has just gotten underway. They just had their first sort of open community meeting last month. And so if anyone's interested in seeing how that's progressing or contributing comments or use cases, you can visit the BioKepler site. Now, in terms of compute, so one of the other big issues that the community is starting to face is where do I run my compute? So there are few institutions that have access to a lot of different compute resources. However, that's not always for individual researchers. They don't always have that option. So one of the other issues that we've been trying to address is how can we actually sort of tie in multiple compute resources into what people are doing in terms of their research and their analysis. And this is important if, for example, one has a very, for example, large-scale analysis. You go into sort of a community resource and all of a sudden you find out that everyone else who's going to a conference is submitting their jobs at the same time, and so queues can get backlogged. And so how do we sort of provide the ability for sort of multiple systems to be used together, for people to come in, associate their own resources with a compute environment to sort of make it expandable and customizable to what you would need to do. And so this is sort of another issue that that we see. I mean, we don't have unlimited compute resources. We do have access to a number of different resources, both at the San Diego Supercomputing Center and also some other National Science Foundation computing resources that we tie together into sort of a virtual grid. And we've also been working with commercial partners such as Cadonis to see how we can do sort of a sort of a mixed hybrid model, of people who can come in, use free cycles, as some people need to sort of push their jobs forward. Like, how can they actually link out to some resources they might have at Amazon or other resources? And this is all work that's dealing with this meta scheduler that decides where these jobs go, and that's another small project which we've just started up. So as was shown before, I mean, the camera portal has a site where one can go. Different ways to actually load in data via spreadsheets. I'm not going to talk about that much, but we have different ways of querying the data, including sort of some graphical query tools, also an advanced search interface. One can go then take data into sort of the workflows. Currently we have more than 24 workflows. There's a whole set of sort of next generation workflows which are coming shortly, which we have running locally as well. And this data is then brought into a dashboard where one can either visualize the data with some visualization tools, or download them or share them with other people in the system. So trying to allow people to sort of create community groups where one can share their data. So I think we were limited to 10 minutes. So I think this is my last slide. Try to do this quickly, keep everyone on time. And when one comes into camera, I mean, camera was funded by the Gordon Betty Moore Foundation, really to focus on sort of marine metagenomics. And one can see that, when looking at the types of analysis people are doing, it is actually, fairly heavily centered on marine metagenomics, but it has broadened, over time. And so there's, a number of other different research projects, so some microbiome research projects that are using the infrastructure as well. And, we look, at various ways to engage with the community and also develop new workflows, new analysis pipelines. So if anyone wants any further information, one can visit the website, but I think that's what I wanted to touch upon this morning.